In this video, I'm going to talk about calculating concentrations in parts per million, parts per billion, and parts per trillion. Parts per million. A concentration of 1 part per million means one part using any unit is present in a million parts with the same unit. For example, 1 gram solute per 1 million gram solution, or 1 gram solute per 10 to the power of 6 gram solution. We can use different units to express parts per million, like 1 gram in 1,000 liters, 1 milligram per liter, 1 milligram per kilogram, or 1 microgram per gram. The most common unit to express parts per million is 1 milligrams per liter. 1 milligram is 1 over 10 to the power of 6 kilograms or liters. This is the most common unit used to express parts per million. Parts per trillion. A concentration of 1 part per billion means one part using any unit is present in a billion parts with the same unit. For example, 1 gram solute per 1 billion parts of solution, or 1 gram solute per 10 to the power of 9 gram solution. 1 microgram per liter is the most common unit. 1 microgram is equal to 1 over 10 to the power of 9 liters. Parts per trillion. Parts per trillion. A concentration of 1 part per trillion means one part, again using any unit, is present in a trillion parts with the same unit. 1 gram solute per 1 trillion gram solution, or 1 gram solute per 10 to the power of 12 gram solution. 1 nanogram per liter is the most common unit. 1 nanogram is equal to 1 over 10 to the power of 12 kilograms or liters. Notice that parts per million, billion, and trillion does not refer to the number of particles, but to the mass of the solute compared to the mass of solution. The equation used to calculate parts per million, parts per billion, and parts per trillion are parts per billion mass of solute divided by mass of solution times 10 to the power of 6, parts per billion mass of solution times 10 to the power of 9, parts per trillion mass of solution times 10 to the power of 12. Sample problem 1. Symptoms of mercury poisoning become apparent after a person has accumulated more than 20 milligrams of mercury in the body. Express this amount as parts per million for a 60 kilogram person, parts per billion, and parts per trillion. What is given? Mass of solute is given, 20 milligrams. Mass of solution is given, or total mass, which is 60 kilograms. Required parts per million, parts per billion, and parts per trillion. Formula for parts per million: mass of solute over mass of solution times 10 to the power of 6. Convert 60 kilograms into milligrams by multiplying by 1,000, then another 1,000, and you get 6.0 times 10 to the power of 7. That's the mass of solution. Parts per million now, 20 milligrams divided by 6.0 times 10 to the power of 7 times 10 to the power of 6. And when you do the calculation, you get 0.33. Parts per billion, 20 over 6.0 times 10 to the power of 7 times 10 to the power of 9. And you get 333. Parts per trillion, the same fraction here, but multiplying by 10 to the power of 12, and you get 3.3 times 10 to the power of 5 parts per trillion. Sample problem 2. Biological magnification, that is the increase of concentration of a substance up the food chain, is a particular environmental problem. A scientific study reported that seabirds living in a particular lagoon contained 25 parts per billion of DDT, although the DDT sprayed water contained only 3 parts per billion of the insecticide. What mass in milligram of DDT would be present in a 4.0 kilogram seabird containing this concentration of DDT? Given parts per billion, 25, mass of solution, or total mass, which is 4.0 kilograms, required mass of solute, or mass of DDT. Convert mass of solution into milligrams. We have a mass of 4 kilograms times 1000 times 1000, and you get the 4 kilograms in 2 milligrams. Parts per billion, mass of solute over mass of solution, times 10 to the power of 9. Parts per billion are given, 25. X, mass of solute, over 4.0 times 10 to the power of 6, multiplying 10 to the power of 9. This 10 to the power of 9 here goes into numerator and is multiplied by x. And we can put 1 here, we don't change anything here, and we cross multiply now. 10 to the power of 9 times x times 1, which is this one here, equal to 25 times 4.0 times 10 to the power of 6. And we solve for x by dividing both sides of this equation by 10 to the power of 9, and we get the answer 0.10 milligrams. Sample problem 3. Dissolved oxygen in natural waters is an important measure of the health of an ecosystem. In a chemical analysis, 250 milliliters of water at the SATP, 2.2 milligrams of oxygen was measured. What is the concentration of oxygens in part per million? Given mass of solute, 2.2 milligrams, mass of solution, 250 milligrams, or 250 milliliters, the same thing. Parts per million is expressed in milligrams per liter, we know now. Convert 250 milliliters into liters by multiplying by 1000, 0.250 liters. Parts per million, 2.2 divided by 0.250, and you get 8.8 parts per million. Or we apply the formula we just learned, parts per million, mass of solute over mass of solution times 10 to the power of 6, 2.2 over 250,000 times 10 to the power of 6, and you get 8.8 parts per million. We convert here 250 milligrams into milligrams, and we get this number here. We divide, and you get 8.8. So we got the same answer using 2 different methods. Some real-world connection here. Lead must not be over 0.015 parts per million in drinking water. Arsenic 0.05. Mercury 0.02. Zinc 5.00 parts per million. The oxygen dissolved in water for fish and shrimps should be more than 2.0 parts per million, and so on. Thank you for watching the video.